Before today's presentation, please allow me to introduce myself. Before, I worked for engineer, but for only China domestic market. I worked for almost 10 years. Later, I was transferred to international department, also for working for supporting engineer, mainly in charge of the supporting work of Middle East and Africa region. As many of you know me, we have seen each other. But for a lot of you, this is the first time you hear my voice, know my name. I hope today I will give you a good presentation. Thank you all for joining with us. Today, we are going to introduce a new article model, ALPS1. As you know, for some clients who cooperate with us for a long time ago, you know, before our article receiver, the name is S82, a very old model, S86. Then later, it is like Galaxy series. Wait a moment. 我这个还没退，等一下啊，退一下，是我的电脑。是我的啊 ，PPT， 可以看见 PPT 对吧？第一页啊，第一页。你是不是应该翻？当然。Later, the new generation is for Galaxy series. You already know Galaxy G1, G1 Plus, G6. Later, some other model. Today, in today's presentation, I'm going to introduce from three main parts. The part one, we're going to have a quick review for our typical article receiver. For the past 5-6 years, we sold. Then we're going to introduce the latest model, ALPS1, the application in some practical scenarios. Part 3, it is the ALPS1 application introductions. Some is available right now. Some function will be, they'll come soon. Firstly, we are going to have a quick review for our typical article receivers. For the past 5-6 years, the first one, it is a Galaxy series, G7, G2, G3, G9. For all of these models, they are equipped with tilt sensor. Before this model, there is low tilt sensor. And for this model, they are also with the Wi-Fi and SOC system. We can easily, by visiting the receiver's web UI, to make some settings. Then we come to another model with camera. We have G2, G3, and Inno 8. This receiver with camera. For G2, there is only one single camera at the bottom. For V3, there are two cameras. One at the bottom, another at the sides. Inno 8, besides the cameras, there is a display. Besides the tilt survey, for these receivers with camera, we can do photogrammetry survey, VR stakeout, AR stakeout, 3D modeling. And now it is our latest model, ALPS1. ALPS1 is equipped with a laser sensor. For this slide, we can see the surveyor is holding the pole paired. You know, before, if we want to measure some points, we have to keep the pole upright over the points. With the paired sensor, if you don't purchase very high accuracy, we can use paired survey. Just keep the pole tip over the point, then we can get the coordinates. It can save time. Actually, for a lot of projects, it doesn't require very high accuracy. Some clients said, I just want to high efficiency. I just want to have this project done soon. So either for 1 centimeter, 2 centimeters, 3 centimeter, I don't care. I just want this project be done fast. In this case, paired survey is very useful, time saving.
Да, но у него еще основная задача, соответственно, вытаскивать координаты.
For previously,
есть using RTK. Мы же в конце, когда обозначим привязку делаем, у нас все получается координаты, верно? Да, но в одном ПО ни в DXF отвести, не обвести, ни выгрузку.
I'll come back soon.
Ya grupea mananya se no dice tu application no se olvida na ko kuma ne se go ai.
Okay, let's continue. You know, when you are using an article receiver, you have to hold the pole, keep the pole over that point. This is a way we are doing for the past many years, past 10 years, 20 years. But now, because of the camera, because of the laser, there are a new trend of survey. It is, we call it non-contact survey. That means it will allow the surveyor to stay apart from the point we are going to survey. We can get the coordinates. No need to hold the pole, keep it over the point. For receivers with camera, we can do it. From here, we can see there are two different models. The first one, the major difference is, the first one is NO8. The second one is V3. The major difference is NO8 has a big display, which will allow it to show more information. Both receiver has two cameras, one at the bottom, another from the side. Another of our model, V2, it has only one camera. For this one, it can do VR stakeout, AR stakeout, 3D modeling, paired survey, but it cannot do photogrammetry survey. Only for a receiver with two cameras, it can do photogrammetry survey. That is V3 and V8. For this receiver with camera, we can do non-contact survey. This slide shows the surveyor. He is taking photo for the target. This is photogrammetry. if he want to get the coordinates, for somewhere, the surveyor, he will take photos for a target from different position. Normally, it will take 5 or 7 photos. This will allow the APP to calculate the coordinates. Besides taking photos, there is another way we can use the camera to take a short video for an object. Normally, 5 to 10 second video, that is enough. This is a photogrammetry survey. So for a surveyor, no need for him to get very close to keep the over the point to get the coordinates. Another application that is AR stakeouts. AR, that is augmented reality. See, traditional way for staking out points, the APP will show us, you go to north, how many meters, go to east, how many meters. Then the surveyor holds the pole, he continuously adjusts his position until finally he reached to the target. That is traditional way. By this AR stakeouts, you can see it will give a guideline from the photo, show us which direction shall we go, how many meters is left. So it is much easier for surveyor, especially for someone who is not very experienced, to find out the targets. Let's see, for this one, this photo and the last photo, what is the major difference? The major difference is for the middle photo, the photo is taken from the side camera. The last photo, the photo is given by the bottom camera. What is the difference? You know, when the target is very near to you, for example, just 5-10 meters, it is near to you, then bottom camera, it is okay enough for guide you to find the targets. But if the target is a bit far from you, like 50 meters, 100 meters, 200 meters, then the bottom camera cannot give you a guide. Then it will use the side camera. So this is a major difference between receiver with a single camera and dual camera. Another function is 3D modeling. Because the receiver has the camera, so we can take the many photos or take the video from objects. From these two images, it shows there is a very old house. The surveyor is holding the receiver just by taking video for this old house. Then the APP, the post-processing software, that SGO, process the images, then give you point clouds. From these point clouds, we can capture a point. You can know the coordinates. You can measure the distance directly for 2 points. This is 3D modeling. Firstly, the receiver in field, it will take a short video, take video for this. Okay, I'll come back soon. A neat problem. It looks like there is a neat problem that we 现在可以是吧？啊，先前那个 AR 方样这儿那个地方是能看见吗？3D 这个3D 现在是3D。Okay, another major function. 现在是3D，看到了吗？对，接着讲。好。Another major function is 3D modeling. It is working simple. The surveyor hold the rover receiver to take a video for some objects. Then the post-processing software, SGO, processes it. Then you can get the point clouds. From these point clouds, you can measure the distance of 2 points. You can get coordinates for any points. In the near future, it can allow you to measure the area or volume. This is how the laser RDK get coordinates. You can see the surveyor is holding the receiver. The receiver is giving a laser beam to the targets. Once the laser beam can focus on the target points, then we can get coordinates from the APP. It is much more convenient compared to photogrammetry survey. Because for photogrammetry survey, you have to take photos for objects for at least 5 to 7 photos or a short video, then upload the photos, image, or video to the controller, then process it. It will take some time. Normally, it will take around 1 minute. Now we are going to give you a brief introduction about laser measurement by video.
Hello everyone, today I'm here to talk to you about laser measurement. During visual positioning, we might encounter the following challenges. 1. When the lighting is too strong or
这个光线昏暗的地方能出来吗？同步了吗？
It is difficult to capture high-quality image data. 2. In certain survey areas where space is tight, it's convenient to move equipment around. 3. If we only need to quickly measure 1 or 2 points, is there a simpler and faster method? Indeed, visual positioning may not be the best solution in certain scenarios. At this point, we can use laser measurement as a supplement.
Sorry, due to the internet had some delay, maybe you cannot see the video. Very weird. So we just skip this slide. We go to next. Let's go back to the previous slides. From these slides, you can know if the pole, the rover receiver, is not hold very stable, even a very slight vibration or shake, it will cause the laser beam spots a big shaking. So how to avoid this kind of challenge, we're going to introduce. In field, you know, it is a little difficult to hold the pole very, very stable. The best way is to use a bipod or tripod to hold the receiver, to let the laser beam firmly focus on the target, to avoid the laser beam spot shaking. Another way is laser forward intersection. From the Service Star app, there is a function. It is called laser forward intersection. By this way, from this image, we can see the sphere is aiming at the same point P, from two different positions. Actually, this is a mathematical calculation. By this forward intersection, it will allow us to get a more accurate coordinate for this point. Another way, it is laser AR. From this image, you can know from the controller, you can see the targets. Because sometimes if the target is a little far from you, then it will be difficult for you to precisely focus your laser beam over the point. If we can use laser AR, this is a function, we can enable it from the app. It will allow the side camera to be open from the controller. From the controller, you can see the target points better. This will allow the sphere to aim to the targets better.激光 AR 的能看见吗？
可以看见，可以看见，能动。
Next, we are going to introduce some practical scenario. Before this, we can know for this new model ALPS1, actually it is something like a combination, or it's hybrid. It is RDK plus laser plus camera plus tidal sensor. This is a display. From the rear side, we can see here, this is the laser sensor is here. This is for camera, side camera. At the bottom, that is the bottom camera. From this image, we can see it is difficult for a sphere to get across, to mirror that point. In such scenario, both by photogrammetry survey or by laser survey, we can get a point. But actually, for this scenario, if we use laser, it is much easier. Just take only a few seconds to complete. Just make your laser beam focus on the point. Then tap the store button, it can save the coordinates. Okay. 关了呀？我看谁的没关，我把它关一下。
那个谁关？那个谁关一下。
啊，好。
你现在你讲的就是其实一直拿到底，中间就是活是不是很大的事情？对，你讲你这个也有后面要做的。
From these slides, it can show there is something we cannot access to it. It is either dangerous or some restricted area. From the left side photo, it is a gas tank, so it is not allowed to get close to it. The right image shows this is a high-grade transformer. Also, we cannot go inside. In this scenario, both by camera or by laser can accomplish this work. Let's see. From these slides, it shows sometimes it's very difficult to measure a point directly because of all kinds of reasons, like this for traffic. We are not able to measure it directly. So in this way, also we can use a camera or laser to make the measurements. From this photo, it is better to use laser because we just need to measure a few points. So by laser measurement, just like in a few seconds, we can get the points. 接下来这个切库的看得清楚吗？这个切库的可以。Another scenario, it is sometimes it is not very bright. It is in dim environment, so we cannot see the target very well. In this case, laser survey, only laser can work well. Because laser beam can let us easily find the targets, then we get the coordinates. From these slides, it shows this is like a city village. If we want to get the coordinates, for example, here, get the coordinate here. That will be very difficult because the reason one is the satellite blockage. So the sphere, to try to get more satellites, the sphere, he has to find a place which is open to let him get enough satellites so the receiver can get fixed solution. So in this scenario, if we want to use a camera to do the photogrammetry survey, it's very difficult because this place, it's a very layered place. You know, for photogrammetry survey, it will ask the surveyor to take several different photos from different positions. But here it's difficult. So if the surveyor right now stayed in the middle of the road, just let the rover to send the laser beam then it will be much easier to get the coordinates. Actually, for so many cities, there are many this kind of place. We call it city village. In such kind of scenario, laser survey can work much better. Now this photo is taken just in front of our office. Nicholas Severe, he want to take some points on ground. He used a camera. In this way, because there are many points to take, so photogrammetry survey is better. That means camera is performing much better than laser. Because A+ Severe has already completed the photo taking, he can get as many points as he can. And if unfortunately in the field he forgot to take some points, even when he go back to office, he can still take the coordinates, take some point coordinate. For example, here. Even he go back to office, still he can just open the Service Star app, continue the work, to get more points. So in such kind of scenario, if more point is required, a camera is better. It performs better than laser survey. For ALPS1, also it supports AR stakeouts. You can see the image. It will give an image, give a guideline, so the surveyor can easily find the targets. Another function is 3D modeling. Because for all of this receiver with dual camera, it can have such function. This is a project for old house, which is done by one of our clients. They made video for his house, then process it with the SGO software, then get the 3D modeling. Besides the above mentioned scenarios, there are some other features either available right now or available in the near future or come to.
点出发。
行了，应该可以了。
你们开你们的电脑先。
再说一下。Hello。
This image. This image shows a sphere. It can get distance even inside the room. The left side image shows it is our office. I just took this photo yesterday. We can use this receiver, just make a laser beam focus on the target points. Then we can get the coordinates. Get the distance, not coordinates. Because inside the room, no satellite, so no coordinates. Only distance we can get. Another feature is laser stakeouts. As we all know, the traditional stakeouts, the sphere hold the pole, try to find out where is the target. He need to make many times attempts, adjust the pole little by little. Finally, he find the points. By laser stakeouts, the sphere, he just staying here. Just make laser beam shoot to the target. The APP will choose your laser beam point, like the deviation, how much deviation from the laser beam spot to the target. You need to go to northeast, how many meters? This is laser stakeout. So the sphere just staying here is okay. No need for him to hold the pole and walk towards the target point. This function, we can use the laser measurement to directly get the area and volume of some object like this house. This function were not available right now, but in the very near future will be available. You know, sometimes if the point, it is not on a plane surface, it is on a vertical surface. For optical receiver, it is very difficult to get the coordinates. With laser measurements, we can achieve this. From these slides, the sphere, he wants to measure the center of a tree or the center of a cylinder, a pillar for this bridge. That is very difficult. Okay.
No picture.
No picture. Can you follow me? Can you hear my voice?
Hear the voice, but
yes,
picture.
we can hear you.
Okay, thank you.
Yes, but no picture.
Okay. Normally, it will be very difficult for either optical receiver or total station to directly get the center of a cylinder. Normally, from some, you need to use that COGO function for offset calculation. But in the near future, we can directly get the cylinder center, the coordinates. It will be very easy. You just make the receiver shoot a laser beam to the cylinder. You shoot for 3 points, then it will calculate the center of this cylinder. In the near future, this function will be available. 接下来一张在球面测量的有吗？瞧瞧。下面一张。Okay. This slide shows the surveyor. He is trying to measure the width of a road or bridge. Normally, we cannot directly get the distance of 2 points. For article receiver, what we have done before is we try to store point 1, then store for point 2, then go to COGO, then calculate the distance of these 2 points. But with this function, it will allow us to directly get the length of 2 points. So it is convenient. Sometimes we don't want to store the coordinates for some points. We just want to know the length of the objects. So it will be very quick. Without saving the coordinates, we can directly get the width of a road or bridge. This function also will come soon. 下一张3D 建模了。This is for 3D modeling. The software SGO will process the data, then it will show us the objects. From here, we can just pick up any point. It will give us the coordinates. We can mark this point, give a point name, give a note or remarks for these points. We can also directly measure a distance from 2 points. In the near future, this software will allow us to directly, just by selecting some points, then we can get the area, calculate the area. Next, some new features will come in the future: point cloud and volume calculations. In future, we are expecting this can be done from the controller software, not from computer software. So in the field, we can see the point clouds. We can get the volume calculated. And more applications is under developing now. We also need your precious suggestion. Thank you all for staying with us. If you have any doubts, have any question, or you can just give us message. We can clarify for you.
Can I ask some question?
Okay, please.
Okay, as I understand, you combine GPS receiver with kind of laser meter?
Right, there is a laser sensor. We integrate that laser sensor to these article receivers. There is a third sensor, there is camera, and right now for this new model ALPS1, there is a laser. So that's why it is, we call it a combination or hybrid article receiver. This is how does it look like? You can see this is the size. This is my phone.
No picture. Sorry.
能看得见我摄像头吗？
能看到有点卡。
The internet is not very smoothly, so the image it will reach you maybe just I need a delay. 不行啊，看不见这个。
可以看到。
应该你可以看见他们不一定。Right now, I'm holding a ALPS1 receiver with me. Here it is the laser beam is coming from here. Laser beam and side camera. At bottom, that is bottom camera. This is the front face of this receiver.
A question.
Okay, please.
As I understand, this is a laser beam that when the receiver is mounted on the pole, exit in the corner like perpendicular to left.
Sorry, I didn't get your meaning very well. Could you please just repeat? Okay, Miss Ram, you have some question?
Yeah, good afternoon, sir.
Good afternoon.
Sir, when we are collecting data by camera, it will create point cloud. So that point, after collecting that point cloud, we have to download that data first, then only we can do some drawing and anything.
Yes, firstly, in field, the surveyor is supposed to take a video from objects. After that, he have to take the receiver back to office.
Okay.
Then download the data from the controller to computer. Then use his computer software, SGO, to process the data. Then it will give you point cloud.
Okay. SGO can do this.
Yeah, SGO.
Okay, thank you, sir.
Okay,
Yeah.
One question, Mr. David.
Yeah, please.
How much range for this laser? Range? How many?
30 meter.
30 meter, huh?
30 meter.
Okay.
But as you know, if, as I introduced, if the surveyor is holding the probe, holding the receiver, let it send the beam. If your hand, if the probe is not hold very stable, once there is a very slight vibration or shaking, then the laser beam spots will give a little bigger, much bigger vibrating. So that's why it is suggested not take too long for the object, just like 15 meter, that is better. To ensure accuracy.
Okay, thank you. How much watt? Watt?
You mean the power consumption, right? How many watts? Power consumption, right?
Yes.
工作时间嘛，对，这个功耗怎么说？工作时间不起什么功耗。
David, may I ask question? You hear me?
Let me check it for you right now. I cannot remember it very clearly, but just very soon I'm going to reply you.
Okay, okay, thank you, thank you.
Question? As I understand, the only way to point the laser on some object is to tilt the pole, right?
Pardon?
Play with pole.
I didn't get it.
You hear me?
Yeah, I can hear you. Can you please come again?
Yeah. So the only way to put the point of the laser on some object is to tilt the pole in proper direction.
Yeah, you're right. You are right. Absolutely right.
Okay.
You have
So
to
if, for example,
to let laser beam to focus on the target. You cannot hold the pole upright. You have to keep it a little tilt, either tilt forward, backward, leftward, right side.
Yeah.
Yeah, you're right.
So in this situation, it's not possible to use bipod or tripod. You just need to hold it carefully. One more thing.
I get your question. I get your question. You know, for a bipod, it is okay. But if you are using a tripod, it is working like in this. You keep the 2 feet of the
Okay, I understand.
ground. Keep another one, the third one, keep it up. So this will allow the receiver can tilt forward or backward. Yeah, you cannot keep all 3 feet of the tripod on ground. Otherwise, the receiver is just upright. You cannot tilt it. Let me show you from this PPT. There is one slide. It is showing. Let me show you.
I can't see your slides. I don't know why. I have no picture for you. No image. Just look what the picture I created.